practice is to measure the coefficient of static friction. In our case, wood and aluminum.
Static friction. It measures the ability of two surfaces to slide past one another. When the number is too high, there's a lot of friction between two surfaces. To measure static friction, we use the critical angle method. This method consists of inclining the board until the aluminum box moves. Another key concept is mass. That is the quantity of matter of a body regardless of its volume or of any forces acting on it. Is the materials that we use. In our case, we use wood and aluminum for the boxes. Also, changes of the mass. Depending variable is the resultant of the static friction and the control group. The result of a static friction given between wood and aluminum found on the internet.
Here are the materials for this experiment. We need a board of wood, a box of aluminum, 3 bags of beans. These 3 bags have different weights. They are a bag of 200 grams, 400 grams, and 600 grams. And finally, a protractor.
Hi, this is our wood inclined plane, and as you can see, here we have the aluminum box.
And now we're going to put 200 grams in the aluminum box.
This is the first attempt. As you can see, it starts to move with 40 degrees.
Now we're going to change for 400 grams in the box. This is the first attempt.
Now we're going to use the 600 bag.
This is the first attempt.
It's like 55.
So to calculate the results, first we need to add all the degrees to get the average of the 10 of them. So first we calculate for the 200 grams, and as a result we got 48 degrees of the average of those. Then we're going to do the same process for 400 grams. And as a result, we got 45.1. As we can see, these results are similar but not equal. For the 600 grams, we got 46.6 degrees. Now, to get the static friction, we have to use the formula tangent of the angle. First, for the 200 grams, you only put tangent in the angle you got, in our case 48, and our result is 1.11. You repeat the whole process again. Now for the final results, we can see that the static friction is not exactly equal, but it varies in a very similar way. So it is true that static friction depends on the material and not on the mass. So So what we learned from the experiment is that it doesn't matter the mass that you use. What matters are the materials. In our case, wood and aluminum. The static friction of these two objects varies between 1.10 and 1.05. So we can conclude that static friction will be always the same no matter the mass of the objects. Sadly, we couldn't find any results on the internet to compare them to our results, but at the end, I think that we did it right. So it's very interesting to know that it doesn't matter the mass, it matters the materials. So this practice actually helped me understand better the practice and to reinforce some knowledge that I already had.
Well, I think this project helped us to understand how friction works with an example of a real life situation. And what I learned about this activity is that the friction of an object is always depending on the surface of the plane and also the surface of the object itself.
So in this project I learned that it doesn't matter the weight of the objects that are falling down, because if they are from the same material, they will have the same static friction.
I really was surprised that even though we apply more weight to the box, it was still in the same angle.
Overall, I thought this experiment was very useful. We got to see this different static friction of materials that we haven't seen before and how it affects the ability to the materials slide past one another.
Experiments like the one we made for this Pia help us students understand the topics that we see in class. These experiments are important is because since we are seeing it in real life, we can understand it better.
Hola, maestro Marco, lo amamos mucho. Y también Nina.